Hello everyone, this is Sarbajit Dutta and welcome to Educathea. Now, if someone asks you what will happen if you throw a ball towards a wall, your obvious answer would be, well, it will just bounce off from the wall. But here, a quantum physicist would disagree. He or she will say, maybe the ball will just penetrate through the wall without actually breaking it. If someone asks you, is the wall there even if you do not look at it? He'll probably laugh aloud and say, obviously yes. How does it matter if you look at it or not? But yet again, a quantum physicist would disagree. He or she will say, well, the moon is everywhere until and unless you see it at some place. Now I'm sure you must be thinking that this is some very poorly written science fiction script. But the sad truth is, maybe our nature intrinsically is so mysterious and weird. Welcome to the world of quantum mechanics. Now let me tell you, quantum mechanics is practiced by both professional scientists as well as the ones in pop culture. The professional scientists are more inclined towards how to use this theory, and they usually do not worry about what this theory actually means. So unfortunately, they have developed this shove it and calculate kind of attitude. They fail to realize that dressed up in mathematical jargon, quantum physics is philosophy at the end of the day. The ones in pop culture, however, take great interest in deciphering the meaning of quantum mechanics and also its implications. But their ignorance of mathematics in quantum mechanics often leads them to some preposterous results. This is why you must have heard that when people cannot explain anything, they tend to use the word quantum here and there.
Do you guys just put the word quantum in front of everything?
At the same time, there are also claims to connect quantum mechanics to what we might call as mysticism. There are legit claims to connect quantum mechanics to Eastern mysticism. Now, there is no problem with that, but then again, people move a step forward and they try to explain miracles and beyond life events with the help of quantum mechanics, like using your willpower to, kind of influence nature. That's probably not true. In fact, this is where Richard Feynman comes in when he says, I can safely say nobody understands quantum mechanics.
There was a time when the newspaper said that only 12 men understood the theory of relativity. I don't believe there ever was such a time. There might have been a time when only one man did, because he's the only guy who caught on before he wrote his paper. But after people read the paper, a lot of people kind of understood the theory of relativity in some way or other, but more than 12. On the other hand, I think I can safely say that nobody understands quantum mechanics.
Now the obvious question is, why on earth are we trying to replace classical mechanics, that is the physics which explains all our day-to-day activities, with something as weird and as vague as quantum mechanics? Why do we want to replace logic, certainty and determinism with illogic, uncertainty and indeterminism? Well, the answer is actually very clear and simple. We have seen physical phenomena, we have seen experiments which forces us to come up with quantum mechanics, which might be weird, but that's the only way out there. Now, I cannot say at the end of the course, you will completely understand quantum mechanics. After all, I'm not trying to defy what Richard Feynman said. But I'm very sure at the end of the day, you will understand why quantum mechanics is so elusive. To do that, let me start with a historical perspective, which is also often ignored. Let us start with light. Now, we all know light is a form of energy which helps us to see. The very fact that you can see me on your screen is due to the fact that light is reflecting from your screen into your lens, and that's why you can see me. Light is all around us. It is also interesting to note that light exhibits various natural phenomena, and this was known to the physicists right from the 17th century. Light moved in straight lines, known as the rectilinear propagation of light. Light bounced back from surfaces, known as reflection of light. When light moved into another medium, it deflected, which is called the refraction of light. And then again, if sunlight is passed through a prism, it breaks into 7 colors, the Vibgyor, as we call it. The obvious question yet again is, why does light execute such interesting phenomena? Why does this happen? The very first answer was given by none other than Sir Isaac Newton. Well, actually, it was René Descartes who originally gave this idea. Newton extended his idea and also significantly elaborated it. According to Newton, light is made up of small marble-like balls, which he called corpuscles, and hence the name of the theory is Newton's corpuscular theory of light. Now, he assumed that these balls are perfectly rigid and elastic, and he could explain all the phenomena that I just mentioned on the basis of this assumption. When you see that Newton's first law states that if you do not disturb a body with an external unbalanced force, then it will continue in a straight line. So will corpuscles, and that's why light moves in a straight line, rectilinear propagation of light. Yes, that's what I'm talking about. You know, marble balls reflect elastically from hard surfaces, and so does corpuscles when they fall on any reflecting surface. And that's why you have reflection of light. Refraction of light occurs because when corpuscles move into another medium, the second medium attracts the corpuscles, and that's why light bends or deflects. Now, once light is well into the second medium, the medium equally pushes the corpuscles from all sides, making the net force zero, and that's why the corpuscles again start to move in a straight line, and that's why after refraction, light moves in a straight line. To explain the spectrum of colors, Newton needed to assume one more thing. He assumed that there are different types of corpuscles, one corresponding to each color. And that's how we explain the spectrum of colors. At the same time, however, there was a contemporary physicist, Christian Huygens, who did not quite agree to what Newton said. He said that, well, light is not made up of particles. Light is a wave, just like a sound wave. The fact that sound is a wave was well known at that point of time. And that's how he gave his wave theory of light, known as the Huygens wave theory of light. He would explain all the phenomena on the basis of his theory. Light reflected not because corpuscles bounced back, it is because waves reflected from surfaces. Light refracted because when the waves went into another medium, their velocities changed. The spectrum of colors was very easy to explain on the basis of Huygens' wave theory of light because every color could be associated with one wavelength. So by the end of 17th century, both the theories were quite established. It was only a matter of choice for someone to favor one theory over the other. Needless to say, Newton had great respect and repute at that point of time. And so the majority of the physics community preferred Newton for more than a century and not Huygens. But then something else happened which shook the foundations of this so-called particle theory of light. What's that? We'll see that in our upcoming lecture. Thank you so much for watching this video. Do not forget to like, comment and share this video with your friends as much as possible. And also don't forget to subscribe to the channel because that would serve as a motivation for me to come up with more such beautiful videos. Also kindly press the bell icon over there so that you get a notification each time I upload a new video. Don't forget to check the description box down there for more updates and have fun and enjoy science.